Hello students, happy Christmas day to all my Christian friends. At the same time, తెలుగు ప్రేక్షకులకు వైకుంఠ ఏకాదశి శుభాకాంక్షలు. Let us continue our class. Power measurement with dynamometer type wattmeters in 3-phase systems. At last class, we have seen what are the different types of methods to measure the power in a single phase and 3-phase circuits with the help of our wattmeter. We have compared the power measurement in a single phase circuit with the help of voltmeter, ammeter and power factor meter. How we are going to calculate power in the circuit with help of resistive load, inductive load, capacitive load. These three instruments are replaced by only one single wattmeter. Same values we are going to get it. That is also we have seen in previous classes in case of single phase circuit. At the same time, the power measurement in 3-phase circuits. The power connected to the load, that load may be connected in star connection or delta connection, and the load may be the balanced condition and unbalanced condition. What do you mean by the balanced condition? So, balanced condition means the impedance value of each phase approximately equal, that is equal Z1 is equal Z2 is equal Z3, where Z1 is equal R1 plus J of X1 in a phase 1 and Z2 is equal to R2 plus J of X2. Similarly, and Z3 is equal to R3 plus J of X3. If these loads are approximately equal, then we are going to apply the same principle. And also we have seen that how we are going to measure the power in a balanced load conditions. So, we have the three methods with the help of single wattmeter method under balanced condition, 2 wattmeter methods and 3 wattmeter methods are generally used in our electrical field to measure the unknown power of a given 3-phase load. Okay. So, how we are connected and how the wattmeter connections already we have seen last class. At a glance, you can see how we are connected single wattmeter to measure the power in a 3-phase circuit. Okay. For example, if we take this is one of the motor which has a connected, for example, star 3 phases, or phase, Y phase. This is the load, for example, we connect the load, motor and motor terminal. Okay, you connect the motor terminal here. Then it is connected to the R phase, it is connected to Y phase, it connects to B phase. And it is connected to the supply R phase and Y phase, B phase. And we connected the IC TP switch, iron clad 444 switch, the fuse, and we connected this directly some, you can say the auto transformer or another starter. What is the purpose of starter? We will see. Okay, starter. From this one, it is connected to our terminals. Now I want to know the power, so I can connect here my CC coil of wattmeter. So what is a wattmeter? Wattmeter has two coils. One is the CC coil, another is the PC coil. Okay, these 4 terminals coil. So this is a M, this is a L, this is a C, this is a V. Okay, now I connected the CC coil in series, then this is a CC coil, and PC coil I connected here through. So for example, you may connect in this another phase, or you are going to connect the another. You can see this is the neutral point. You can take this as neutral. Okay, this is a star point. You can see this is star point. Now I connected for phase value, for example, here. So here connected. Okay, then this is a M, this is the load, this is a common, I shorted here, and this is a V connected to the neutral of this one, N or Y B neutral. Okay, here also we are going to get, so here it is connected, sorry. Okay, neutral. Now we connected such a way that, so when supply is given here, R phase, Y phase and B phase, 3-phase supply is given and started with help of the starter auto transformer, then the motor will run at that condition. By wattmeter indicates the what is the power consumed by this motor in one phase. Okay, so that is the wattmeter. So based on this wattmeter, for example, it's showing under normal condition, suppose if there is a load, a small off load is loaded on the motor rotor, then it is drawing the current something. For example, I connected the ammeter, it drawing the current of 5 amperes and voltage across this is equal, for example, we take the 400 volts. Then so at that condition, the wattmeter indicates what is the reading here. The indicate, let us assume W is equal to 120 watts. Then what is the power consumed by this total motor? Then one phase is taking the 120 watts. I want the total power. Okay, total power is equal to, I can write it, that is equal to how many phases? 3 phases. Okay, 3 into 120 watts. What is the value? 12 3 is a 36, 0. So this is the total power consumed by this motor under running condition with a load of full load condition. Okay, so this is a power measured with help of wattmeter, voltage measured with a voltmeter, and current measured with the ammeter. So in a balanced load with help of single wattmeter method. Okay, last class we have seen. Similarly, so how we are going to use the unbalanced condition with 3 wattmeters at a time. Same case, what you are going to, so for example, you take the same principle here. So this is the same motor taking the phases. Now this is R phase, Y phase, B phase and neutral. So it's for example connected in star connection. Okay. Now similarly I am going to connect here R phase, Y phase and B phase and neutral. The ICTPN switch, you can take the ICTPN switch, the fuse, this is a link. Okay, now I connected the one starter auto transformer, whether you connect to the star delta, automatic star delta transformer, as a starter, or you can use the, if the motor capacity is less than 5 HP, you can use the DOL starter also, we can use the DOL starter also, we can use 3 phase. Now in this case I am going to connect the 3 wattmeters method. So here what you are assuming, this motor, this R phase winding, Y phase winding and B phase winding may not be exactly equal. That means impedance of R phase and impedance of Y phase and impedance of B phase are different values. Okay. So that is what is impedance, Z is equal to R plus J of X. Okay. So that is the resistance and leakage reactance of each phase. That is equal, for example, here. Now in this case, then what will happen is the different load windings will draw different current ratings. Then the power consumed by each phase may not be equal. At that condition, if you measure the power in one phase into 3 times, it may not give the accurate value, because different. One phase maybe takes more power, one maybe take the less power. So we cannot multiply. In that case, under unbalanced condition of a 3-phase load, we can measure with the help of 3 individual separate wattmeters. That how we are going to connect it? So you are going to connect each wattmeter in each phase. Okay, let us connect it. So here I am going to connect in R phase. So here I am going to connect. This is the equal R phase. I am connected the one CC coil connected in series to this phase, and here I connected the PC coil connected to the neutral. Okay. So this is equal W1. Now I want to connect another phase. So I want to connect another phase, that is you take the green color. Okay. Now you take this phase. Now I am going to connect here, sorry, where is the back? Okay, this one. Now I will connect it. I am connect RCC coil here, and the PC coil is connected this way. Okay, this can be W2. Now you take the another phase. In this case, I will take the yellow color. Okay. Now you take, first of all, you remove this one connection here. Now you connect this one CC coil, here connect the PC coil, this one. So this is equal W3. Okay. So dear students, here W1, so here what is happening here, you can see here. Now you can take, this is the black color. Now here when R phase, Y phase and B phase are neutral, the ICTPN is closed condition. Okay. Then by starting the starter, the motor will run. If the motor is run, then we are added some load. Now load is 3/4 load added on the motor, full load. Okay. I full load current is flowing, 3/4 of full load current is flowing. At this condition, it will draw the current that can be measured by the ammeter, and it will take some voltage, I can measure by the voltage. Now what is the power taken by this phase, indicated by this wattmeter W1. Okay. This is indicated with the W1. What is the power consumed by the second phase is the W2, and what is the power measured by that is the W3. Now we can observe it, CC coil connected in each phase, but the PC coil measured one phase and another neutral, another phase, another neutral, another phase, another neutral. Okay. Then it will measure the phase 1, the phase 2 and the phase 3, R phase, Y phase, B phase. Now what is the total power? So total power is equal to, so we can write it, that is equal to W1 reading plus W2 reading plus and W3 reading will give the total power consumed by this motor. Okay. These are the another method to measure the 3-phase power in a 3-phase circuits. But here what is the need? We require the 3 wattmeters is required. It looks some awkward. Okay, so what is the famous value? That we are going to use the 2 wattmeter method is the best for the balanced and unbalanced conditions. Last class we have seen also we proved that the instantaneous power consumed by each motor is equal W1 and W1 plus W2 is equal IR and ER plus IY, EY plus EB, IB. We derived that thing. Okay, so what is the how we are connected that one? So at a glance you can see it. So what is connected here? So this is OR phase connected, and here is the connected to this other phase. Okay, now here we connected the another phase connected here, and this is connected to this one, and here so here there is no connection of anything here. Okay, now and this is a neutral connected. So what is happened here? Oh sorry, so I connected them, though no nearby, here connected in between the. Okay, so this is a red, I taken this as a red color, and this connected here and this connected here. Okay, now here connected the our machine. This is a machine and this one. Okay, so such a way that we connected, and R phase, Y phase, P phase. So that is connected here W1, this is the W2. W1 CC coil is connected is purely on R phase, okay, R phase, and whereas the PC coil connected between the R and B phase. PC coil connected between the this one. What is the current? IR. What is the voltage across this one? That is called ERB. That is the power. Now here what is the current? IY. What is the connect pressure coil connected? Here this is the EYB. So based on this one and this one, we calculated this in previous classes, the instantaneous total power. We derived this already. What is that one? Instantaneous power read by so W1 and W2. So we already calculated the total power is equal total power W1 plus W2. We proved that. So W1 plus W2, 2 meters reading added, then we are going to get it I into R, and so that is equal to I into R, and we are going to the ER phase value, okay, plus I into Y, E into Y, plus I into B and E into B. So individual phases values we are going to get it. So that what the current consumed in phase, current consumed in phase, current power consumed in this phase, 3 phases, power equal to read by only 2 wattmeters, which is W1 and W2. So this is proved in previous classes. Okay, that is maybe the it may be balanced or unbalanced condition, whether load is balanced and unbalanced condition. Okay, so in this class we are going to learn further what is done if this load is only balanced condition, and in this case we have calculated the instantaneous the power. I want the load is balanced. Now load is balanced condition, balanced, and it should be not the maximum power. I want in instantaneous power, I want the RMS power, root mean square power, in terms of root mean square power values. Okay, so in the let us see same unbalanced, balanced already you have seen. If the load is only balanced condition, I want to note that total power so is equal to, in terms of RMS values. In W1 plus W2 I am going to find it. Okay. So, dear students, let us see. Now, here the power measured in wattmeter 1. So, here load is connected in delta. Okay. So, delta connected. Now, I want to the power consumed by this W1 and power consumed by W2 I am going to find in terms of RMS values. Okay. So, what is the W1? So, VRB into IR. So, IR is the current flowing in the R phase and VRB is the voltage between R and B phase. In this case, you can see it R, Y, B connected. I am going to write the in terms of this one. Okay, let us as electrical students, we should be known with vector diagram. Okay, let us do this one with vector diagram. Okay, so this is the vector diagram. So, will you draw this vector diagram? So, by seeing this one, we can easily draw the vector diagram. How you are going to write it? So, take it simply. So, what is our main load? Load is, for example, take the, for easy understanding purpose, you take it in star connected load, okay, for simplifications. Then what, how we are going to write? So, here is the R phase is connected and this is connected Y phase and connected this, for example, you take it as another phase. Okay. So, then you can say it, you take the black color for the common. So, this is connected here, this is connected here, this is connected here. Okay. Indicate this is equal to R phase, this is a Y phase, this is a B phase. Okay. Now, I am going to connect here. So, one CC coil in R phase and your PC coil connected into this B phase. Okay. Now, here I connected CC coil and connect the PC coil connect across this one. Okay. This is called W1, this is equal W2. Okay. Now, indicates the current values. Let us assume this current is equal to IR. Okay. So, the current is equal IY, IB, B currents. Now, it is connected voltage between the R and B. So, can I write it? This phase pressure coil is equal to simply E R B. Here, what is the pressure coil here? So, this is a Y B. I can write E Y B. Okay, this just you remember this thing. As you know that this is the inductive load, the current which is flowing is lagged by the this line voltage. So, that is why I indicated here. You can see what is the IR, this is the VR. So, here you can take the VR and you phase, you VR phase, VY phase, VB phase or phasor voltages. Let us easy to understand. Okay. So, we can draw this diagram. Are you following? I think this diagram is the vector diagram is a very easy. Are you going to draw this vector diagram? Okay. Let us, I will explain. Don't worry. So, I will explain separately. Here, what is connected here? Just dear students, please don't confuse. Simple follow it. Okay. Now, I am drawing the once again. This is a R phase. This is a one winding, this is the unwinding. Okay, now it is connected here, it is connected here, and it is connected here. Now here connected the one CC coil, here connected another CC coil, and here connected and CC coil and PC coil, and is connected to this phase. Okay, here connected this one. So this is known as the current is taking, this is equal to IR, we can say V or phase values we taken for consumption. So what is the CC coil? Current is flowing in the this is a CC coil, this is a PC coil. What is the CC coil current? IR. This is equal. What is the PC voltage that is connected between the, what is this one? E R phase, and this is the R, this is connected here, you can say YB. Okay, so VB and VY. Okay, this is connected across this two phases, R phase and B phase connected here. So we can say this V or B. Okay, now similarly we connect the another here. Okay, then what is this one? So current, which is the current flowing, the same I Y current, IY current. The pressure voltage here is the, what is the voltage? That is equal EYB. Okay, so this is a diagram. Just we have seen, and the star point also we have seen. The star point is this one. Now in this case we connected the two wattmeters phase line to line. Okay, so this is one line, this is another line, this is another line. Let us assume VR. Okay, so here VR comma VY comma VB are phasor voltages. Phasor phase values we take phase voltages. Phase voltages. Okay. Now, so under the here balanced condition, this is the phase voltages. Let us assume VR is equal to V, Y is equal to V, B is equal to, so we can take directly V phase. That means, so what is the voltage? For example, 3-phase supply voltage is 400 volts. Okay, line to line voltage is 400 volts. What is the phase voltage? 400 by root 3, we are going to the 231 volts. So we are taking the 230 volts is the, this is the phase voltage, this is the phase to phase voltage, that is the line voltage. Now we taken these values are here, phase voltages. Okay, so all are we are assumed as a equal voltages, that is the V phase RMS values. Similarly, the phase currents, what are the phase currents? That is equal to IR, and also because these are also equal balanced condition, I Y is equal IB is equal, we can say that is equal to I phase current. Okay, we take in the phase current, RMS phase value, RMS phase voltage. Now another factor is equal to the power factor angle phi, the phase angle between the respective voltage and current. Then this is the phase angle between, so this phase that is equal, we can say that is equal V phase and I phase, that is the phase angle between the V and I phase, that is the cosine angle between the voltage and current is the power factor, that is the phase angle we can say here. Okay, now so what is the phase angle between one phase, we can take it. So before that one, so you see the figure once again. Okay, simple, I connected here, what I have connected, R phase, Y phase, B phase connected in star, and R phase we connected the one wattmeter. Let us, this wattmeter is equal to W1. Okay, so here you can see it. Sorry. So, taking this is a W1, at the same time this is equal W2. So, W1 and W2 connected in such a way you can see it. Okay. So, now based on this circuit diagram, I am going to write the phasor diagram. So, how to draw the phasor diagram? So, you can see it. So, here similarly you can take it. Okay. Now, you have this one. Let us assume you take the phase values first, colors. Okay. Here let us assume, so this is equal to thickness, you can increase it, R phase, we can write it VR. Okay. VR. Next, correspondingly this is a current lagged by IR. Angle between the VR and IR is the phi angle. Okay, one phase. That means here IR and VR and phase angle between this is the phi IR. Okay, for one phase. Similarly, because in this case voltage is a leading, current is lagging into the inductive load. Similarly, write the another phase, Y phase, you take it. So, here Y phase 120 degrees apart, this is a voltage, we can write it Vy. Correspondingly, the current also lagged by Iy, phase angle is the phi r, we can take the another phase angle. Now, we take the, what is the angle between the Vr and Vy? 120 degrees. So, this is the angle is the 120 degrees. So, we know that R phase, Y phase, B phase both are 120 degrees, 120 degrees and 120 degrees, we know. Okay. I need not to tell. Now, B phase, you can take the B phase. So, what is the B phase? Here 120 degrees. Okay. So, this is a VB phase values. Correspondingly, the current is lagged by some IB. What is the phase angle? Phi B, for example, same phase angle. Now, we can observe what is the values? VR, Vy and Vb are 120 degrees apart, and IR and Iy, Ib also lagged with corresponding to its their voltages. These all are the RMS values. Okay. Now, I want to write what is the phase angle between the resultant of this wattmeter current and wattmeter voltage. Let us, you can take it. Here what is the this wattmeter current values, you can see here. What is the values? IR. What is the voltage here? ERB. Okay. IR and ERB, I am going to write it. What is the phase angle between this? The phase line voltage and phase current, line current. Okay. So, now it is the connected, that is equal to, I am going to write it, the phase angle between. So, what is the voltage? One pressure coil is a VRB and current is equal to IR. So, I am going to write this one, but there is no VRB. We know the VR, VB, but there is no VRB. So, can I write it VRB? Can I write it VRB is equal to and VR minus VB, I can write it. Okay. If you know these values, so we know this value, I can write what is the phase angle. Okay. There is a phase angle between the VRB and VI, I am going to calculate, that is equal phase angle, this for example. What is the phase angle? Whether this one or something, anything. That means I am going to write it this one. So, here what is the VRB? VR minus VB. Now, can I write it? So, you can see. So, this is a VR, I know. VRB, this B value this direction. if I write it in reverse direction here, for example, I can write it in this direction. Okay, this VB is equal this one. I can write it the minus VB. Okay, same 180 degrees. Then from this one, so what is the VB? So I can vector sum of these two values. So I am going to get is the V or B. So this is known as the V or B. We got it. Okay, V or B, we got it. Okay, now I want the phase angle between this V or B and this IR. That means this angle I need. Okay, so what is the phase angle VR and VB is equal now? It is what is the this one? 60 degrees. This is 60 degrees. So VR and VB is angle is equal 60 degrees. You can see this is a 120 off the 60 degrees. Now it is a VRB is a 30 degrees now. This is the phase angle between this is equal 30 degrees. So what is the angle? This one 30 degrees. That is called VR and VRB is equal 30 degrees. Okay, now I want here. So what is the phase angle between the VR and IR? What is the phase angle? That is equal to phi angle. Here you can see. So I can write it clearly. What is happened here? So this is equal VR. Here is equal to IR and angle is equal to phi r. Okay, now we got it. So this is equal to V or B voltage, and so this angle is equal to, I am going to get is the how much? So you are going to get is the 30 degrees. This is equal 30 degrees. I want the angle between these two. This angle is 9. I know that this is a 30. I know the phi. Can I write it? The phase angle between the V phase angle. Okay, phase angle between V or B and IR is equal to, what is the VR total? This is equal to 30 minus the phi. I can take it. So this is a phase angle. The phase angle between VRB and IR. So here the angle means, you can see here, that is equal to IR and ERB. So this takes the IR. This is equal, voltage is equal, physical voltage is equal to ERB. Okay, current is equal to IR. What is the phase angle? This is equal to 30 minus phi. This is the phase angle. So that is the, what is the power? Power is equal to V into I into cos of this phase angle. We are going to do the power in this phase. Okay, so let us assume that is equal to, so W1. I can write it. Okay, so W1 I can write it. What is the this one? So I can write it the W1 from this Phasor diagram. W1 wattmeter reading is equal to, so I can write it the voltage, that is the pressure carrier voltage, or B, and I or phase current, and phase angle. What is the phase angle? Cos of 30 minus 5. This is equal phase angle, the equation 1. Okay, this is the equal values of this one. Similarly, you find the W2. So W2 value. So what is the value? So we are going to write it the W2. So W2 is connected here. What is this one? So that is equal IY, and what is the voltage here? Pressure current voltage. I can write IY comma voltage. What is the EYB? So I can write it EY is a EY minus EB. Okay, that is the phasor voltage between these two. I am going to write it. Then I want to know the what is the phase angle between this and this. That is equal phase angle. Okay, now we can, from the vector diagram you can see here. Okay, what is this vector diagram? So I want to know that what is the values are required? EY minus EB. So Ey, where is the Vy? This is the Ey. Eb means this Eb. Okay, already we have this minus Vb and this one. You write the equation here. Okay, so now can I remove this one? So I can remove these values. Okay, I can write the freely. Now we can write it. So this is equal to value. Okay, this is equal, I can write this value. What is this one? E, what is the value? Y B. So this one. What is the phase angle I required? So from, you can increase that one. Okay, I want this one. Okay, next I want the current. This is a EYB, got it, and IY. Where is the IY? So this is the IY. So I want the phase angle here. So what we are going to get it? So now here what is happen? Up to this is equal, we are going to 30 degrees. This is known as the phi angle, we know. So can I write it? What is the phase angle between these two? So IY and this one phase angle, can I write it? That is equal to, here I can write it, phase angle between the phase angle. Okay, phase angle between I, Y and V, YB. Okay, YB, voltage YB, this one is equal to, what is the phase angle now? You can see this is the phase angle I require, 30 plus 5. I can write it 30 plus 5. This is the phase angle between these two. So I can write it W2 is equal to, what is the voltage? That is the voltmeter reading is a VYB. What is the current? IY cos phase angle. What is the phase angle? This is the phase angle. Then I can write the 30 plus 5. This is the second equation. Okay. So now you can see it. You can see this is the first equation. This is the second equation. Okay. Two readings values we got it. Now from this one we are going to add W1, W2. What will happen? We are going to see. Okay. So let us see. Dear students, please don't confuse. One by one. So we are going to learn. So what is happen here? W1 is equal to, what is the value? So we have got it. W1 is equal to V R B into I R into cos 30 minus 5. Okay, this is the one equation, we got it. And W2 is equal to, what is the value? V YB I Y cos 30 plus 5. This is equal second equation. So two equations are drawn from this vector diagram. This vector diagram is drawn based on this our circuit diagram. Okay, as an electrical student, you should know what is the circuit diagram, what is the vector diagram, how we have drawn. I think you have understood. Okay, clearly. Now, based on this W1, that means W1 reading, the wattmeter reading here, what is the its equivalent values we derived, what is the equivalent values we derived. Now, there is a power measured by this phase and power measured by this phase, we are going to add. So, we assume that W1 and W2 will give the total power consumed by the three-phase load. Okay. So, that is why we know the W1, we know the W2. So, these are the two equations. Now, total power is equal to, what we are assuming? Total power is equal to W1, total power is equal to W1 plus W2. Add it. That is called 1 plus 2. We are going to add it. Okay. So, now by adding this one, So, we are left side, we are going to the W1 plus W2. Okay. Now, in this case, what we are going to voltages, that is equal V R B into I R into cos 30 minus 5, okay, plus this is the one equation. Okay. W1 plus V Y B I Y cos 30 plus 5. This is the second equation. Okay. Now, these two equations we written. Now, here we assumed as V R Y. Okay. We taken the, this values are the, all are we taken the balanced condition. So, simply I can take the load is balanced condition. So, we are going to V R Y, V Y B, V B R, that is equal. So, line voltages, we can take the simplification of V L. Okay. Then I R is equal to I Y is equal to I B is equal to take the I phase. So, we can take the this value, or we can take the line current, that is so called the line current, because it is connected in star. Okay. So, we can take the, this is the current is the, we take the IL, because with the line values we required. Okay. VL IL. So, here substitute instead of IY, substitute the IL, we substitute VYB VL, the line voltage. Okay. For the simplification. Now, this equation becomes, so please remember, simple I written, what I have written? Simple, I added W1 and W2. So, I am going to get this all is added. Then from this equation I am going to get it. Okay. So, here W1 plus W2 is equal to, so can I write it VL IL cos 30 minus 5 plus VL IL cos 30 plus 5. Okay. So, this is simplified. Now, you can take it. So, VL IL is a common, VL and VL. Okay. Phase and voltage taken. So, what is the value? Cos 30 minus 5 plus cos 30 plus 5. Okay. So, this is a taken out. Now, based on the mathematical formula, what is this one? So, we know that cos values is equal to cos 30 cos theta plus sin 30 sin theta. Just simply write it. Okay. So, we are going to get that values. So, that is equal to, so I am going to write it, this equation, write it. So, I can write it, this is equal to, so VL IL is a common. Okay. From this one I can write it, this one cos 30 into cos 5. So, minus resistance we come to plus sin 30 into sin 5. So, this is a, I am going to get this value. Okay. Now, plus I am going to write it here. So, what is this one? Cos 30 cos 5 minus of sin 30 sin 5. Okay. This is the equation. Now, you can see it is a minus value, here plus value. Okay. Simply will goes. Okay. Then write this equation. So, that is equal to VL IL Okay, now we are going to get this term and this term only, cos 30 cos 5. So I can write the cos 30 cos 5. You can write it the 2 into cos 30 into cos 5. Okay, so now I can write it. What is the substitute the value? That is equal to VL IL into 2 into cos 30 is equal, you can write it the root 3 by 2, okay, into cos 5. 2 get cancelled. Now what is the value? We are going to get it. That is equal to VL IL, okay, into root 3 into cos 5. That is equal to, it is not nothing, root 3 VL IL cos 5. Okay, so that is equal to W1 plus W2. What is this? This is nothing but power, total power consumed by 2 wattmeter method. This is a 3-phase supply, 3-phase power, root 3 VL IL cos 5. Okay, so that means the total power consumed indicated by the 2 wattmeters, that is W1 and W2, indicates the total power consumed in a 3-phase load. Okay, dear students, what is the 3-phase power? That is the root 3 VL IL cos 5, where VL is the line voltage, IL is the line current, cos 5 is the phase angle between the voltage and current. This is the value. If you know the power factor, if you know the IL, if you know the VL, so we are going to calculate the power. That power is equal to the 2 wattmeters connected only in 2 phase, not in 3 phase, under balanced condition. If the load is balanced condition, if you are connected the 1 wattmeter one phase, another wattmeter another phase, if you measure the sum of these 2 wattmeters will give us the total power consumed in 3 phases. That is, we proved it. Okay, so let us assume this equation is equal third equation. Okay, so now this is the third equation. Now W1 plus W2 we are going to get it root 3 VL L cos 5. I want to know that W1 minus W2 I required. Okay, W1 minus W2 I know. So I know the W1, I know the W2. It's simple. Here what is happening? So you simply take it's a minus value only. Here you are going to that, what is the value here? So this is, you are going to the minus value. Simple. Okay, so minus value, so what will happen? Now in this case, instead of sine values, in this case the cos value will goes. Simple. Okay, so let us do that. So what is happen here? Simple. So we are going to get it. So W1 minus W2. Okay, so same equation I can write it. What is that one? So VL IL cos 30 minus 5 minus I taken here, and that is called VL IL cos 30 plus 5. Same equation, a minus value only. So what will happen? So that is equal, I can take the VL IL and taken outside. Here I am going to that the cos 30 cos 5 plus sin 30 sin 5. Okay, now same thing is here minus is taken out. Now you write it. What is this one? Cos 30, okay, and cos 5 minus sin 30 sin 5. This is the equation. Now here is the same thing. Okay, so I can write it VL IL cos 30 cos 5 plus sin 30 sin 5. Now in this case what will happen? minus of this value, that is cos 30 cos phi minus to minus plus sin 30 sin phi. Okay. Now what is happened? So here you can clearly see it. So here what is happened? So this is a minus cos 30 cos phi plus cos 30 cos phi. This one get cancelled. Okay. Then this and this sin 30 sin phi sin 30 sin phi, both are positive. So I can take the 2 into it. So I can write it, that is equal to VL IL into 2 into sin 30 sin phi. I am going to get it. That is equal to what will happen? VL and IL 2 sin 30 is equal to 1 by 2, okay, into sin phi. What is the value? So 2 is get cancelled. Then we are going to get is VL IL sin phi. I am going to get finally that if I that one W1 minus W2 value. So let us assume this is the fourth equation. If added W1 plus W2, I am going to get the root 3 VL IL cos phi. If subtracted the wattmeter readings W1 minus W2, I am going to the VL IL sin phi, that is the reactive power. Okay, this we got it the third and fourth equation. Now I want power factor, phase angle I required between these two. Phi is required. Then I am going to calculate with help of the wattmeter in terms of wattmeter readings. I want the phase angle in terms of wattmeters. So please take it. So here 4 by divide fourth equation by third equation. Okay, what's the fourth equation? So this is called W1 minus W2, okay, by is equal to, what is the value? So I am going to write it is equal to VL IL sin phi. This is the fourth equation. What is that third equation? W1 plus W2. Where is the third equation? Just we taken the third equation. Where is that one? Oh, this is the third equation. Okay. So W1 plus W2 is equal to, we are going to these values. Okay. Simply substitute these values. Now that divided by root 3 VL IL cos phi. Okay. This is VL get cancelled, IL get cancelled. So I can write it, this is equal sin theta by cos theta is equal to tan theta. Then I can write it tan theta, or we can write tan phi. We can tan phi by root 3. That means here, so that is equal tan phi by root 3 is equal to, what is the reading? You are going to get it, W difference by addition, W1 plus W1 or minus, yeah, take it minus this one, W1 minus W2, this value divided by this value. So we are going to W1 plus W2. Okay, I want the only tan phi. Then so send this value, tan phi is equal to root 3 into W1 minus W2 by W1 plus W2. This is the phase angle can be found from given two wattmeter readings. Okay. Suppose I want the power factor. So how we are going to calculate this power factor? Similar, I want this one, phi I required. So this phi is equal to, center this one, tan inverse of, okay, root 3 into W1 minus W2 by W1 plus W2. Simple. This is one. I want the power factor. What is the power factor? Power factor is equal to cos phi. I know the phi, simply I require the cos phi. So can I write it? So multiply with the cos both sides. So cos phi is equal to cos here tan inverse of root 3 W1 minus W2 by W1 plus W2. Okay, this is a power factor of 3-phase balanced load with RMS values, okay, with help of wattmeter readings. Okay, dear students, you can see it. Okay, so these are the power factor. Okay, have you understood this one? So it is a very easy. Okay, so let us see in our PowerPoint. Okay. Now see in this one. Okay, same thing. What you have observed here, already we have seen that. So W1 plus W2 is equal to root 3 VL IL cos phi from the vector diagram. That indicates that what is the value? W1 plus W2 is equal to algebraic sum of two wattmeter readings is equal to the total 3-phase power, that is called root 3 VL IL cos phi. Okay, so that is equal to here this value is equal to this value. Okay, W1 plus W2, this is value is equal to this value. W1 W2 is equal algebraic sum of two wattmeter readings, and root 3 VL IL cos phi is the total 3-phase power in a given load. Okay, so this already we have proved from the vector diagram. How we have drawn this vector diagram just now we have seen. Okay, so this is a one vector diagram. Now what is happened here? W1 is equal to this value and we drawn. So W1 this value, W2 and this value, and W1 plus W2, these both are. So what here? W1 plus W2, this is the one equation. Now so we are going to calculate this root with the W1 minus W2. So we are going to get that another value, just what is given. So from the above derivation with respect to the case balanced load, 2 wattmeter method can also be useful to measure the power in 3-phase unbalanced loads. In case of balanced load, the 2 wattmeter method is useful to find the power, also power factor. Okay, so as we know that wattmeter readings in 2 wattmeter method is given by the case balanced load, W1 is equal this much and W2 is equal this. So by subtracting we are going to W1 minus W2. So we got it. So what is the value? Just simply we do that and we are going to get it. So VL IL 2 into sin 30 into sin phi, that is equal VL IL sin 30. So we got it that also. Okay, so this is the final equation. Now here, so what we have got it? W1 plus W2 is equal to root 3 VL IL cos phi, okay, and W1 minus W2. So we got it from this equation, that is a VL IL sin phi. Okay, so two equations. If added to wattmeters readings, we are going to get the total power. If subtracted from 2 wattmeters, we are going to the reactive power. VL IL sin. Okay. Now, and also we know that, so we got it this. So 1 by 2 equations, we are going to the tan phi. So what is the tan phi? That is called, we are going to get it here, the equation tan phi is equal to root 3 into, so W1 minus W2 by W1 plus W2. Just now we have seen this one. Okay. Now we are going to know the power factor. Therefore the phase angle phi is given by, so tan inverse of root 3 W1 minus W2 by W1 plus W2. Okay, and power factor cos phi is given by So multiply the cos phi is equal cos into tan inverse of root 3 W1 minus W2 by W1 plus W2. Okay. So these are already we have derived mathematically on equations. Okay. Now study of effect of power factor on wattmeter readings we will see. Okay. So what is the time now? So let us conclude this one. Okay. We will see in the next class that time. So what we have seen in this class? In this class we have seen that here the power measured in a 3-phase unbalanced load with the help of W1 and W2, we found that RMS values in the form of line values. So we find out that so W1 plus W2 is equal to, we are going to the total power, that is root 3 VL and IL cos phi, and power factor phase angle, that is phi is equal to, we are going to tan inverse of root 3 and W1 minus W2 by W1 plus W2. So we derived from the Phasor diagram these values we found. Okay. So in next class we are going to find that what is the effect of load power factor on wattmeters. If power factor changes from lagging to leading or low power factor to higher power factor, what are the indications of our power factor readings in wattmeters? So this is a very interesting. So while we are going to do the experiment on our 3-phase induction motors and sometimes the meter readings will goes in the opposite direction, reverse direction, below the 0 reading, and sometimes 2 wattmeters shows the equal readings. Sometimes it will shows the 1 wattmeter as a 0, 1 meter is the another. That indicates that 1 wattmeter is not working, just it is creating a phantom. But that depends on the power factor of the motor. We will see. So what are the changes takes place into W1 and W2 with respect to change in power factor. Okay. So let us wait for that class. So I think this class is explained clearly to you. So how this W1 and W2 shows active power and reactive power and phase angle. Okay. Thank you for listening my class.